Bridges are amongst the world's great iconic structures, symbols of connection or maybe separation, of flow or maybe obstruction, of elegance or functionality, or at their best, both together. And if I then think of innovation in bridges, I think of architect-inspired designs, new materials, simulation and digital twins, maybe 3D printing, or even smart bridges covered in sensors and connected to the web. My guest today is a civil engineer who takes a very different view of where innovation is most needed for the bridges of tomorrow. A view that is better suited to the circular economy. It's a form of innovation that relies less on technology and more on human skills of craft and know-how. His name is Theodore Zoli, one of the bridge design industry's most recognized American figures. Ted is National Bridge Chief Engineer at infrastructure design firm HNTB, and he spoke to me from his office in the Empire State Building in New York.
You're listening to The Innovator's Journey, a podcast about the lives and careers of creative people, technology, and the future of work, with your host, Jonathan Winter.
Ted Zoli, hello and welcome to The Innovator's Journey.
Thanks, Jonathan. Happy to be here.
Before we start, very briefly, how would you describe what you do and why it matters?
I think it's straightforward what I do. I'm a bridge designer. In that sense, I design bridges mostly for vehicles, but quite a bit of transit bridges as well. And these are structures that last 100 years or so they outlive you, or at least they should. And as a designer, I'm really creating the instruction set, if you will. So I'm not making these bridges. I'm making the instruction set for these bridges.
Great. And tell me why it matters. I mean, obviously a bridge takes you from A to B, but why does what you do matter?
Well, so, I think bridges obviously are fundamental to the way we move about, both as people and goods and services. So it's very clear that bridges are maybe the impediment for progress in many circumstances. And so they're such a necessary part of our infrastructure. And when they perform badly or they need to be taken out of service or replaced, we're very well aware of what they mean and how important they are, but we somehow seem to forget their importance when they're just doing their everyday thing. And this is a lot of what I think about engineering, right? When we do our job right, we don't know it, and that's a great thing. And so for me, I think what's important about what I do is I'm the sort of character who tries to make sure our bridges last longer, or they're easier to repair or replace, and so that we don't need to think about them much.
Sounds like unrecognized heroic work to me. Now, this podcast is called The Innovator's Journey, so I'm keen to hear a little bit about your personal and professional journey, Ted. Where does the Ted Zoli story begin?
So I was born on a road job. So my grandfather started a road building business about the time of the Depression in the United States, so in the late 20s. And I was born on an interstate project, mostly in a part of upstate New York that's known as the Adirondack Mountains. And my grandfather's business was very good at cutting through rock. So I've always been around large-scale civil engineering projects, but also this idea about building things in places that are difficult. Yeah, so I would say that's a good sort of fundamental understanding of my growing up. And then I was very much involved in the road building business growing up, and I started working very early, very young. So that's maybe also something that's an important thread in all of this.
Sounds as though there was a sort of inevitability about your career. Who or what influenced you most in those early years then? Was it your grandfather and your father or other people?
Well, yeah, certainly both. And for somewhat different reasons. My grandfather was someone who was keenly capable of making things more efficient. And I think that's the trick with road building, and particularly doing road building in difficult circumstances. And so he was sort of an innovator in the sense that he was great with coming up with new ways for construction equipment to be able to process rock and stone. Using equipment as a competitive advantage, I think, was something that really ran through his entire career. Where my father's different, I think. My father had a sense that a broader approach, a sort of dabbling in many different things, would lead to insights or lead to changes in business and business strategy. So he really grew up in the beginning of the digital computer age. And so I think he really leveraged computing in ways that turned out very different from the general construction business. So my grandfather was sort of laser focused on construction, and my father was laser focused on everything but construction, I would say. So he was really a very different character.
And what about your own aspirations? At what point did you think you might end up in engineering or design?
The fourth grade story for me is maybe a bit of an embarrassing one, in the sense that we had one of these competitions of write a 1 or 2 page story about who you want to be as you grow up. And I had a sort of clear eye to this very early on. And so I wrote why I wanted to be a civil engineer and was fortunate to win the competition. And you get to spend the day with someone who is a professional, and so I spent the day with a county engineer, and the most consequential piece of work that he wanted to show me as this wide-eyed fourth grader was the newly built sewage treatment plant and the sludge beds and so on. And I thought, this civil engineering stuff is not what I thought it was, or maybe encompassed quite a bit more than I wasn't expecting. But
it didn't put you off.
Yeah, it didn't put me off. That's right.
And you've talked about having certain advantages in growing up. I think your education was fairly, I don't know, I might call it elite, was it? Privileged anyway?
My grandfather, who had no education, felt all his children needed to be well educated, and that certainly got passed down to me. So education, I think, was a real focus for all of I have 4 brothers and sisters, and for all of us, it was really a very consequential part of growing up. And so high school for us, that secondary school was I went away to a prep school that was really an amazing educational experience. And particularly, I think it was a focus that you needed to be well educated and sort of clear-eyed to be able to make your way in the world.
And although your education itself sounds quite privileged, in life you weren't just mixing with wealthy people, were you?
So the summers, so I think maybe just as important was that I spent my summers with my father's employees. And
tell me what they were like. Just describe the characters that you met. And
yeah, exactly. So in the Adirondacks, you had the choice at that time. You could either go to school, and high school wasn't mandatory in many places, or you could go to work. And so I grew up around, especially in the shop, I grew up around guys who had not finished high school, went to the woods and were tree cutters, were lumberjacks. And some of them couldn't read and write very well. They could write their names, but that was about it. I would help them fill out their time cards, that sort of thing. But these guys were incredibly talented, brilliant people, particularly around mechanical systems. And you would think, I can tell you this, taking apart and putting a transmission back together for a ready-mix concrete truck, for me, was a lot more complicated than American history was in high school. So, I had this deep experience of people who weren't educated in the conventional sense, and really being exposed to their know-how, just as much as I had that counter experience of being around, people who would be university professors and such. So I think that was a great balance for me.
Kind of double education.
Yeah, really a side-by-side education.
Yeah. And alongside a relatively, in some senses, privileged upbringing, it wasn't without sort of personal challenge and experiences, was it? In particular, you had a couple of situations as a child which were...
Yeah. I had lost the ends of my fingers on my right hand in a work accident the summer when I was 13. And this was one of these, it's a pretty well a construction accident. It was a fan guard of a generator was missing a small portion. I slipped and my hand was exactly in the wrong place at the wrong time. And so the tips of 3 of my fingers were lost. And
you were working there age 13?
Yeah. So I was working at a sand and stone plant, a plant that we would say was just processing sand and stone for ready mix concrete, more or less. And
earning pocket money?
Yeah, exactly. My father was also into restoring old cars, so I think he took my paychecks and we bought a 1936 Packard that I still have. But that year of the loss of the ends of my fingers, I think the hardest part of all of that was just going back to prep school with hands in a bandage still and trying to explain to people what had happened. And I think somehow that experience, it's really very minor in most perspectives, but you have the sense a bit, especially in the prep school environment, that you're disfigured in some way. And I think just coming to grips with what that's like and what that means, I think it was fairly formative for me.
And you had another near-death experience, didn't you? Closer to death this time.
Yeah. Just a few years after that, I had what are termed grand mal seizures, one on Christmas Day, and that's associated strangely with the loss of fingers, where your brain does some resorting. But yeah, I had, heart stopped, lungs stopped breathing. This is at Christmas dinner. My father gave me CPR, and I ended up in the hospital for a few days, and then subsequently doing a lot of work. Maybe 8 months later, when I had break from prep school to try to sort out what was going on, and ultimately I've been seizure free since then, and I'm not medicated. But that moment of really. And it's just a moment, right, where you're at a circumstance where, hey, you may not make it or you may not survive. I think that was a fair amount of getting through high school, was not being really sure how much time you had.
So you went on and you went to Princeton, engineering degree, and then a master's, I think, in a year or so?
Yeah, that's right. Yeah, at Caltech. So I had a very theoretical undergraduate and graduate school training in structural engineering. And so I think I was uniquely prepared to be a professor and uniquely unprepared to be a practicing engineer, of all things. And so I think a lot about that. When we're preparing young people for the future, how much know-how is necessary versus how much a larger understanding. I think my first few years, I really felt the need for catching up, and so I spent a lot of time, probably more than is healthy, in the first decade or so of my career working, and it certainly paid dividends. But I would say it was a sort of a raw investment of time.
And your first job was with the firm that you're still with, is that right?
That's right. Yeah, I've been with this firm. It used to be called Howard Needles at the time. These are old partnerships that started. Most of the oldest engineering firms in the United States were started around railroads. And my firm is no different. So we're based out of Kansas City, and it was 4 partners in 1914. So we're still around. Now we're called HNTB. There's the initials of the partners, but and no longer a partnership. But yeah, that I think many people have really no idea of who to join and why. So I was absolutely fortunate at landing where I landed. I think I was just frankly lucky.
What led you to them?
I decided that New York City would be the place to work in structures and bridges, which is not surprising. The vast majority of engineering firms have offices in New York. And so I had 6 interviews, and I thought this was the firm that some of my theoretical background, particularly in computing and in soil structure interaction, some sort of arcane bit of structural engineering, which required a lot of modeling. I felt like I could do some of the work they were doing with computers. And I thought, I could really help these guys. And of course, it's embarrassing because they were the ones who needed to help me in hindsight. But I thought I really could maybe help with this particular problem. And that was my sensibility, is where could I be useful, as opposed to which gave me the best offer, or which firm I thought had either the best credentials or the best bridges.
And so you ended up working in the Empire State Building.
We were a firm that started in the city in 1922, I think, when we opened our office in New York. We always had a bridge practice. And the bridge practice, when I started, was maybe 20 people. And the office was maybe 40 or so people. And now we're almost 500 people. And we have a number of floors in the Empire State Building. So we've been very successful and appreciative for that success in New York. And now we're the largest bridge office, and so on.
And you talked at the beginning about the lifespan of a bridge outlasting obviously any career and even life of an individual human. So I'm kind of seeing this as a sort of planting trees kind of profession. I think you talk about the evolutionary approach to design. I mean, how is that even possible if the feedback loop is years and years?
So it's exactly that, in an evolutionary sense, right? And I think if there was a Hippocratic oath for engineers, I would say it would be improve upon my good ideas and kill my bad ideas unceremoniously. And this is something I think a lot about. I also feel, and this is the other piece that's crucial, is that I will rely deeply upon those who go after me, who need to fix and take care of the structures I've designed, just as I feel a deep responsibility to take care of and keep after the structures that went before me. I think this is also, if there was a Hippocratic oath, this is also something I would say that structural engineers owe each other. Is this sensibility that it's a continuum of the work we do, we're responsible for each other, and that we need to take that responsibility seriously.
I love that idea of a professional community and the continuity of it. That's really nice. So before we talk about your innovation itself, I asked you to think of an artifact that represents your creative journey. What have you chosen, Ted?
Yeah, so this will seem completely strange, I think, but it's very relevant to at least the way I think about bridges as artifacts. So I'm very interested in poetry, and particularly Chinese poetry. And there's a couple of characters within the Chinese poetry that are incredibly well known, the sort of thing that any school child would learn. So they're intrinsic to culture. I think this is something we don't have in the United States. I think maybe you could say this is true of songs, of popular songs, but not of poetry. But in Chinese culture, there's some poems that are so intrinsic that everyone knows them. They may not know the poet, they may not know the dynasty they were made, but they would know them. And I think they just underpin culture, and they're intrinsic. So I like this idea of engineering being intrinsic, that you don't know who designed the thing. It doesn't much matter. The good design, becomes, it sort of looks like it should be. And what I'm fascinated by in terms of Chinese poetry is this: it's about 1,000 or more years of what is called rivers and mountains poetry. And it's really the Tang Dynasty poets are the ones that I like the best. And it's incredibly spare. There's two that I think a lot about, and one is by Du Fu, and another is by this character Wang Wei. And they're both so ridiculously famous that any Chinese person will know exactly what I'm talking about, and most everybody else will think I'm nuts. So I think bridge engineering at its best, it's only what's absolutely necessary is there. So it's a spare, very economic form that's trying to do a lot, and then it's intrinsic to culture. So to me, I try those two sensibilities, right? Am I adding something that's unnecessary? Is it really the sparest what it can be? And then is it intrinsic? Does it seem right? And so there's a Confucius, an expression that I like and that I have somewhere in my office. It's called 子无邪. Thought's not twisty. In a sense, it's like this idea that when you get it right, it's very clear-headed. It's very clear-minded. And I think that sort of that pure expression of a structural form, spare, I would say. The idea of Chinese poetry for me is spare, and that it really takes an enormous amount of work to come up with the few words or the few ideas that make for good bridges, and certainly in this case make for good poems.
Thank you. We'll be back shortly to talk about the work you're doing now and your vision for how work itself is changing.
You're listening to The Innovator's Journey, a podcast about the lives and careers of creative people, technology, and the future of work, with your host, Jonathan Winter.
So Ted Zoli, the innovation we're featuring today is your work that helps to prolong, extend, give life to bridges for a greater period of time, and specifically the emergency replacement of one bridge that was failing. And I know that the development of a bridge for you is, you've used the phrase fitness landscapes, which I haven't come across before. So fitness for purpose and kind of exploring, evolutionary sort of exploration of what's right for a particular purpose. Tell us a little bit about what's innovative in your work.
Maybe a few things here. One is the sort of evolutionary sensibility about a fitness landscape. For me, the idea is a simple one, which is that the way we were taught engineering, and really the whole field of engineering, grew up around this idea of what I'll say is more the scientific aspects, this idea of structural analysis. Can we understand what the structural system is doing, and then this gives us the opportunity to optimize each component of the structural system in some way that yields to efficiency. And in my view, it's absolutely a crucial part of the, let's say, the 1900s to the 1930s. And this was also in the context when material costs were very, very significant part of the overall costs of the structural system. So there was a natural sensibility about, can I use the least amount of materials possible to get a safe, efficient structure? And so now 100 years later, I'm finding that the fitness landscape, so the idea of what makes a bridge good, has very little to do with material costs. So we're finding that the material costs are becoming a smaller and smaller part of the overall cost of the structural system.
So the constraints have changed, and therefore, if I asked you where is innovation most needed today, you're going to give me a different answer, aren't you?
Exactly right. So just if you think about evolution and adaptation, right? Once you change, it's the problem with the Galapagos Islands, right? Once you change the setting, then you need to change the system. And so I'm very much interested in trying to understand what the new landscape is. And for me, the idea that what's changed significantly is that we need safer structures. Yeah, we clearly, the tolerance for a structure being taken out of service is much, much lower than it's ever been. So the time it takes to build the structure and even the cost associated with its building become the dominant form. So if we're looking for efficiency, and I like to think that all I do is I take other people's money, so taxpayers' money, and make public good, right? So this is the sense of bridge engineering. So I'm trying to take public dollars for public good. So efficiency is still crucial, but I'm saying that material efficiency is no longer meaningful. So all of the tools we use to make the structure just as light and use as little material as possible are ill-adapted to this other landscape, right? Which is now, can I make it safer? Can I make it easier to build? Can I make it faster to build?
And so what are you doing that's novel?
Yeah, so I like the idea about emergency replacements because it's just that, right? We find ourselves in circumstances where we can't be without the bridge we've relied on for a generation or two. And so those projects tend to make people think a lot about what went wrong with the old bridge, right? And how to avoid that, right? How to not be without a bridge.
I mean, am I right in thinking that if there's an emergency replacement, something's gone wrong? It shouldn't have been like that.
Exactly right. Exactly right.
Hasn't been done, or whatever.
Yeah. So it's it's exactly that problem. Either maintenance hasn't been done, or it was so difficult to assess the structure's safety that it ends up going a bit too far, huh? So to me, it's this idea, right? We need to have a reliable measure of a structure's safety so we know when to intervene. And if the interventions are very difficult, we're going to be risk prone. And I feel like this is a problem of repairability. Yeah, if it's difficult to repair, then we're going to tend not to repair structures, and they're going to
creates risk.
Yeah, it creates risk, and also this end of life emergency need.
So tell me about the Lake Champlain Bridge then.
The Lake Champlain Bridge is a bridge which uses 2 or 3 ideas. One about constructability, with the idea that it's a bridge over a lake. It's difficult to get very large construction equipment in place. So we typically would use water-based cranes for a structure like this, but we don't really have the ability to set up large water-based cranes here. And so in this sense, the way the bridge is erected is that the approach structures are used as the crane. And so the arch is delivered by barges. The width of the barges is well known because there's locks. That's the only way you can get into the lake is with a lock. So you know the width of the barge that can be used. And so the arch is sized so that it can fit on 2 barges. It can be brought into place and then lifted with the approaches so that the approach structure is the crane, so to speak. And for me, that's an idea of not just how to build the bridge, but also how to unbuild the bridge in the future, right? The same technique can be used in reverse. And the structural system is not designed just in the final condition, but is designed throughout the construction process. Yeah, so this idea that we can just look at the bridge when complete, I think, is also a misunderstanding of what our responsibilities are. So this idea of how the bridge gets built and what steps it takes and what's the interim stability of and safety of the components, something I think a lot about. And my argument is the bridge can be made safer than a crane typically. So cranes have smaller margins for lots of reasons than structures do. So I like this idea.
So use the bridge as a crane then.
Yeah, use the bridge as a crane.
Yeah.
But the other piece of Lake Champlain that's maybe interesting is the idea of using crossed cables. So I'm very interested in this idea of network arches. So typically when you have an arch bridge, the cables are oriented vertically. And I've done a lot of work promoting the idea that we should be using crossed cables. So these cables that cross at least twice. And this ends up being a much, much safer structural system. So these systems can tolerate the loss of 1 or 2 or 3 adjacent cables.
What sort of circumstances are you trying to protect against?
So it can be deterioration, it could be fire, it could be vehicular impact. I'm interested in these systems that are stable regardless of what the intervening event is, right? I've described this looking at artifacts and the work of others who went before us. And what comes to mind are either lattice trusses or covered bridges. So in a large part of New England, we have these bridges that are built with timber. They typically have crossed members. And the reason the bridges are covered is to prevent rot. And many of these bridges are hundreds of years old and have quite a bit of rot in them. And the beauty of these crossed members is they tolerate damage beautifully. And so I love this idea that a network arch is just a new version of a covered bridge.
The same principle.
Yeah, it's really the same principle. And the beauty of one of the challenges with timber bridges is it's difficult, although not impossible, to replace the diagonals with network arches. It's really quite straightforward to replace the cables. So you get the idea that it makes the structural system much more replaceable in its own lifetime.
What was the most challenging part of that project?
Well, so yeah, it's a great question. So the problem with an emergency replacement project like that is that the design limits how soon the construction can start. So a very aggressive time frame was proposed for that project, and we also have, and I'm sure this is the case in many places, we have a prolonged environmental review process. And this bridge was next to pre-Revolutionary War forts and 10,000 years of Native American history. So we had lots of environmental challenges as well as this need to design very quickly. So we got through the environmental process by placing the new bridge exactly on the same alignment as the old bridge. And then also we limited any subsurface disturbances to what was disturbed in the bridge's original construction. And so that was very successful. That environmental process takes typically 2 to 4 years. In the US, we did in less than 4 weeks. And then the final design we did also in incredibly rapid So it was a 10-week design period. So that would also take more like 10 months. So these are very accelerated design and permitting windows. And yeah,
The team must have worked well together to achieve that.
I've got a great team around me, and it was very much like being at university again. Pizza at 2 a.m, all-nighters before submittals, and so on. So it was an enormous effort, but we had good fun doing it. There's something about rising to that sort of challenge. It's also with emergency bridge replacements, there's that moment that you recognize how crucial the work you do is to the people who use the bridge. And this particular bridge there was not a lot of people in this part of the upstate New York, near where I grew up in Vermont. But these people shared a hospital, they shared a fire department. Farmers had farms on both sides of the lake. They couldn't take in their crops when the bridge was taken out of service. So you really have a sense of how crucial a bridge is to a community or to communities. And I think that ultimately was what adds a lot of fuel to designers' tanks, is to recognize how important the work you do is to people's lives.
If we just think about the future then, and the future of your profession, what's driving change in the way that civil engineering and bridge design is done these days?
Well, so certainly in my practicing career, the amount we can do with a computer, both in terms of real design and detailing and how we present the work we do to contractors to fabricate and construct, that's changed dramatically. The challenge is that most of what I just talked about in terms of innovation is not well defined in terms of those sorts of workflows. So computer-aided design and manufacturing, while that you would think helps us fabricate more quickly and design in a way that's more fabricatable, what's interesting is that that's not actually turned out to be the case. And so the fabricator's workflows are not well integrated into the designer's workflows. And certainly the erection and the transportation of these components is not well integrated into either. And I feel like there's a lot of work to do there. And much of it, Jonathan, for me, works better in a craft model than it does in I would just say an educational, the traditional model of university education. And
that's interesting. What's the reason why a craft model is crucial? Is it because there is something in every project that is unique? Is it the context? Is it?
So it's a little bit of all of that. But there's a certain amount of know-how that I think happens in fabrication and erection engineering that's just not codified at all, right?
Can it be codified, or is it actually not amenable to that?
It's possible, but if you were to say how many different ways can we design an arch bridge, it's pretty limited. If you say how many different ways can we erect an arch bridge, this is a very different question. And in different circumstances, different techniques work remarkably well or remarkably poorly. And I would say a lot of what I've done in my practicing career is to try to learn from not just the finished work, not just the artifact, but the difficulty we had in getting the artifact in place or getting it out. I think either can be very important, lead to very important insights. But what I would say is that this opportunity space, if we think about, all what we're learning with chat GPTs and the like, and machine learning and so on, these do a wonderful job at data sets that are well articulated and that we have good access to. And if the opposite is true, we're really resistant to those sorts of opportunities. And I would say fabrication, steel fabrication, even concrete fabrication, concrete forming, erection engineering, these are not well articulated, and yet we're bringing new innovations. There's been more development in accelerated bridge replacement in the last 20 years than anything in terms of design. We're in that Renaissance period.
I'm wondering, Ted, you're talking about kind of new models for how to do a whole project, and
that's right.
Almost uniquely human. If you look forward 10 years, what will a civil engineer and a bridge designer, what will their work be like?
I think the uniquely human part will be this know-how that this the sensibility, this learned experience of how to fabricate and erect bridges will be brought back into design. And so the human piece in all of that is really a know-how piece that I think is craft. It's also an expectation, a societal expectation about we need to do this more sustainably, more responsibly. And in my view, if we can do this more rapidly, right? If we can respond more rapidly to an event, so you don't expect the bridge replacement to take 2 years and to be very disruptive. You expect something quite different.
Yeah,
and
I guess,
that we,
you politically, it's much harder to invest in maintaining something than it is building something. Everybody likes a shiny new something, but actually continuous investment in maintenance gets missed the whole time, doesn't it?
Exactly. I also think there's a moment at which we were building these very grand structures, and bridges were, in some sense, the new icon, the new signature of a community. And I also wonder if that's as well positioned as we might think in this larger landscape of what our needs are and what our responsibilities are. And so, like you say, the politics of a grand new project are wonderful, but the let's say that the downside of not being able to provide a basic level of service, especially for the health and well-being of the cities that seem to have only grown in population and complexity. I just think that's going to be the measure of how we are looked at as a practice, as a field.
Thank you. Well, it may be a sparse approach and a modest approach to bridge design, but I have to say that it's worth looking at the Lake Champlain Bridge because it's absolutely beautiful. I mean, it's a work of art, I think. It's a wonderful project for the local community and for the rest of us to look at from a distance. So congratulations on that one.
Thank you for that.
Can we finish, Ted, by I'd like to invite you to give some advice to your younger self. What would it be if you had one piece of advice for your younger self?
I think I would say to my former self that learning the process is not nearly so important as learning the meaning of what you're doing. So it's the meaning making, I think, that is much more consequential in the choices you make as a designer. And I didn't understand that. I was so worried about getting the numbers right. I wasn't nearly worried enough about making sure I knew what the numbers meant. Yeah.
And if you also had a message for the whole world, if you had a giant billboard on which you could write anything, what would you say?
Yeah. Well, I'll stay in my lane as I'm a bridge engineer. I would say this is that bridges are these parts of our built environment that we so deeply rely on that they're intrinsic. And that's not to say that that's not their rightful place. I think they should be intrinsic to the way infrastructure works. But it's also that we need to make careful investments in them so that we are not without these vital pieces of infrastructure when we most need them.
Ted Zoli, thank you for sharing your story, your innovation, and your vision for the future of work.
Much appreciated, Jonathan. Thanks for this time.
Thank you for listening to The Innovator's Journey with me, Jonathan Winter. If you enjoyed today's story, do share it with your friends and colleagues and subscribe to make sure you hear future episodes. This podcast was recorded in Riverside, edited and transcribed automatically in Descript, with algorithmic music from SoundDraw and artwork generated with DALL-E. The rest was human.